Hi there, this is Math 7, Unit 2, Lesson 10. We are introducing graphs of proportional relationships today, and we're going to see how graphs of proportional relationships differ from graphs of other relationships. And you began today's lesson, again this is always just a little recap of the lesson, then we'll get into the homework. You began today's lesson with some points that I asked you to plot. Remember our points, this is the x value and this is the y value. And so our initial part was plotting 0, 10, which is plot right there. 1, 8, which was right there, 2, 6, which was here, 3, 4, which was there, and 4, 2, which was there. When you plot those points, what are some things you notice about them? You might notice, for example, a couple things. We might say that these points all seem to line up, don't they? They seem to line up and make a line for us. That's one thing we notice. If you connected them, you could actually make a line. And you might also notice that the pattern here seems to be the same once again. It's going down 2 and over 1, down 2 and over 1. So there's lots of things you might have noticed with your classmates happening with this graph. It just points there. There definitely is something taking place. We know it's going down as well. That makes it interesting, right? So it's usually a lot of our graphs so far have been kind of going up and things like that. This is going down, which is just different to look at. All right, we know our origin is over here. This is our starting point for lots of graphs if we're starting at 0, 0, but we're starting up here at 0, 10. So just some things you might notice as you take a look at that graph. When you look at a chart, for example, or a table, we've talked before about tables and that you might have a table to show some information. In this case, it says some t-shirts cost $8 each. So we know that the price for one t-shirt is $8 each. And that's represented over here in this graph. We have x and we have y, and in terms of what x represents, x is going to represent the number of t-shirts, okay, and y is going to represent the cost, because if I have one t-shirt, it's going to cost me $8, okay. In terms of our k value, our constant proportionality, our y over x, our y is 8 and our x is 1, so our constant proportionality is 8. Okay, so we know our t-shirt is the x value, our cost is the y value, and the proportional relationship, we look at it, should be 8. I can verify that by taking that constant proportionality and putting it in place here and just double checking. 1 times 8 is indeed 8, 2 times 8 is still 8, 3 times 8 is, 2 times 8 is 16, and 3 times 8 is 24, and I can keep on moving down and find some other ones and make sure that indeed there is a constant proportionality that makes this a proportional relationship. Okay, now these are the t-shirt set, that's the table. You can take that table information and we can actually plot it down here on this graph. What we could say, for example, is that we know that one t-shirt, and notice this is going up by 2, so 2, 4, 6, 8, and 10. One t-shirt is going to cost $8 there. 2 t-shirts is going to be $12, $14, $16 there. 3 t-shirts is 24, so it's going to be about there. And 4 t-shirts is at 32. And 5 t-shirts is at 40. And 6 is at 48. So that's what a plot would look like in terms of the t-shirts down here in the bottom to label the graph, and over here the cost, okay, for how much it would cost. These points, while they are in a line, right? Now we don't have to connect the line though. Keep this in mind. You don't always have to connect the line. We call these discrete points. We call them discrete points because the line is not connected. Okay, what we're seeing is that, well, if I'm buying t-shirts, I'm buying them in whole quantities, right? 1 shirt, 2 shirt, 3 shirt. I'm probably not going to buy 2.5 shirts, am I? That just wouldn't make a lot of sense. Are you going to go out and purchase 2.5 shirts? Probably not. Now, if you could buy 2.5 shirts, I suppose it would cost something along that much right there, right, to keep in that line, but you would never buy 2.5 shirts. So you don't need to connect those lines because these are discrete points. I'm only buying them in quantities of whole numbers, like so. There are other things that you can buy a part of something, right? So we'll take a look at that in just a little bit. Okay, so that was the basic part of what your lesson was today, was taking a look at what you did before tables, looking at the constant of proportionality to see if there's a proportional relationship, and plotting that down on some sort of plane. Okay, You then, with your classmates, were given some tables and some graphs, and I don't have that here to go over with you, okay? This was a class activity, and you had some tables and graphs, and what you're looking at is you're looking at what was the same, what was different about the various graphs that you had. And so you're just analyzing what kind of graphs you had and what was taking place within those graphs and having discussions about them. Okay? So in terms of the lesson summary for the day, we could say that one way to represent a proportional relationship is with a graph. Okay? And so here's a graph, for example, that represents different amounts that fit the situation of blueberries cost $6 per pound. So that's our situation we're talking about. Blueberries cost $6 per pound. So we know, for example, that if I have 1 pound of blueberries, it's going to cost me $6, right? So I have two different elements here. I have my weight in pounds here, okay, and I also have my cost in dollars here. So I have two elements that I'm comparing, the weight and the cost. So 1 pound of blueberries costs $6, 2 pounds cost $2. Now, recall before, with the last graph we saw, we talked about something being discrete being just the points. In this case here, I can have a line because I can actually buy 1.5 pounds of blueberries, right? I can actually buy that much, and if I bought 1.5 pounds of blueberries, that would actually be a point on the graph because I can actually purchase that. Okay, so in this case here, I can see different things. I can see that 2 blueberries, 2 pounds would be $12, 3, 18, and then even over here 27 would be 4.5, or 4.5 is 27. There's a proportional relationship there. You could turn that into a table if you wanted to, right? We could do our weight, and we could do our cost, and we can line it up like this, and we could say 1 pound is $6 and 2 pounds is $12, right? And so on, just like you've done before. And if we wanted to see, was there a constant proportionality? Sure, there would be. We have our x and we have our y, and we could say it's 6 over 1, which is 6, and verify that all these times 6 do equal the one beside it. So that's what that part looks like there. Okay, so this says, for example, we could, for example, buy 4.5 pounds of blueberries or 1.875 pounds of blueberries. So all those points in between actually could exist. Okay, so that's kind of the cool part about today's lesson. Okay, and we also talked about discrete ones because you're making something like a sandwich, or before where you only have one, maybe you only have a price for 1 or 2. Anyways, our point here is that graphs that represent proportional relationships have a few things in common. So if it's going to be proportional, it has to have a couple things in common. It needs to be a straight line, and it has to go through the origin. These are key things here. If it doesn't have a straight line and it's not going through the origin, it's not a proportional relationship. That is very, very essential to what we're going to need to know going forward. It has to make a straight line, and it has to go through the origin every single time. So when you take a look at these guys here, these points, if I was to plot them out, go like this, to this, to this, to this, to this. Is that a straight line? Nope. Okay, they're not on a line. So we'd say not proportional here. Over here, is that a straight line? Yes, but what are we looking at? Does it go through the origin? Nope. So it doesn't go through the origin. It has to start at the origin here, and it has to be a straight line. It could be a straight line like that. It could be, if it starts at the origin, I can make it steep and go like that, but it needs to be a straight line, and it has to start at the origin in order for it to be a proportional relationship. Okay, so you're going to take a pause there and work on your homework.